Hello guys, we are back with our next lecture. In this lecture, let us continue with the code optimization, guys. Okay, so when we talk about code optimization, the only thing with respect to this stage is this stage or this phase is completely optional, guys. Basically, the goal of this particular stage is to reduce the space occupied. That's it. So the output will be the same. It might reduce the space occupied and it might make the program to run faster, but it's thing is that only it's not going to change the output or anything. So even with the optimization or without optimization, the result will be same. So process of reducing the execution time of the code without affecting the outcome of the source program is called as optimization. Okay, yes. Okay, so to be clear, there are total 8 different stages or 8 different types of optimizations, guys. Okay, yes. So shall I write them down and explain you, or shall I directly explain you from the book? So I think writing them down and explaining is will be better, right? Yes. So the first type is a code folding, guys. So what do we mean by code folding is, so assume that we are having an expression x is equals to a plus b plus 2 into 3 into 4, 3 plus 4. So to be clear, to execute this thing, do we need to run our program, guys, or you can internally execute it and convert this expression into in this way? So which is better, guys? So if your code is having this thing or this thing, which is better? So this is better, right? So anyone who learned programming and everything, most of the people will prefer rather than writing in this way, right? The reason is because this thing will not waste the time, right? So the time might not be a lot, but it's going to optimize it. That's it, right? Yes. So these type of conversions. So any kind of a constant multiplications. So what are these, guys? 2 is a constant, 3 is a constant, 4 is a constant. So even after I multiply these values, even after 100 years, so the result will be same, right? Even if I multiply now, the result is same. Even while executing, if I multiply them, I will get the same result. So indirectly, I can conclude that the result is same. So I can fold it, right? So what I'm doing, I'm making a bigger value into a smaller value by folding it, like a big expression into a single expression. So that is nothing but a constant folding. And remember, only constants we are going to fold here. Got it? Yes. So moving on, the second type is a constant propagation, guys. So assume that we are having a two constants, a pi equal to 3.14 and we are having x equal to 360 divided by pi. So whenever we are having some constant value here, so do we need to store it there and in runtime only do we need to substitute here? No, right? So whenever we want to save some time or we want to optimize, instead of writing there and in runtime getting the value of pi, you can update this statement into 360 divided by 3.14. So this process is nothing but a constant propagation, guys, right? Yes. And if you execute this thing before only, so using calci or something, if you execute 360 divided by 3.14 and you updated this value of x is equals to 114.64. So what is this? This is nothing but constant folding, right? So we folded this constant into a single value, right? Yes. So here we have applied both of them, right? Yes. So you understood constant propagation means that value will be going to its locations, right? Yes. Okay. Similarly, moving on to the third one, that is a strength reduction, guys. Okay. So when a computer is performing multiplication, it is going to spend lots of cycles, guys. So to reduce that cycle, instead of doing multiplication, if we do addition, that will be of lesser cost, guys, in cycles. So that is nothing but strength reduction. So whenever we write any kind of programming, it might be in any programming language, most of the programs perform these type of things, guys, to reduce the cycles. So even if you are performing 200 into x, and instead of that, if you write 200 times x, this is more optimized than this, guys, when it comes to the cycles. Okay, yes. Okay, so now you understood about strength reduction. So now moving on to the fourth one, that is algebraic simplification. So assume that we are having an expression a is equals to b into 1. So at that time, why do you need to write b into 1? You can directly write this, right? Yes. So this is nothing but algebraic simplification. Similarly, if you are having in this way, so you can directly write it as a b, right? Yes. So this is nothing but algebraic simplification, right? Yes. Similarly, moving on, assume that there is a redundant code elimination. So there is some redundancy in your code. So x equal to a plus b, y is equals to a plus b, z is equals to a plus b. So do I need to calculate again and again? I will calculate once and I will store it in x. So now instead of redoing that a plus b again, so I can directly write y equal to x and z equal to x, right? Yes. So that is nothing but redundant code elimination, guys. Got it? Yeah. So repeated code which is available, we are eliminating it. Okay. Yes. And moving on to loop jamming. Okay, so observe here carefully, guys. So here there is one loop and this is another loop. So these two loops are independent, right? So that loop is not dependent on this. So this external loop is running how many times, guys? It is running 11 times, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 1, 2, 3, 11 times, right? Yes. And this inner loop is running also 11 times. So indirectly this assignment will be done how many times, guys? 11 and 2 11, 121 times, right? Yes. And here we are having one more loop where we are assigning a y value 11 times. Okay, so why do we need to run these two loops separately, guys? I can write this exact value here, right? Y here. So indirectly this will run only 11 times. So that is only our requirement. So that can be done directly, right? So that is nothing but loop jamming. So indirectly inside one loop you are placing the other loop. Got it? Yes. Okay. Yes. Okay. So that's what we have done here. Okay. Yes. So instead of writing in the first line, we wrote in the last line. So nothing. There is no issue, right? Yes. So that is a loop jamming, guys. And similarly loop unrolling. Okay. So assume that we are having a particular loop which is running how many times, guys? Like 1 to 99 means indirectly you can say it is 99 times, right? Yes. So assume that a loop is running 99 times, guys. Okay. So at that time what we can do, so let us make it equal to, so that becomes even number. Okay. Yes. So let us assume the loop is running 100 times. Okay. So now this loop is running 100 times and what it is doing? It is just printing the I value and incrementing it. Okay. So now I can unroll this loop, right? So indirectly I can reduce this 100 to 50 and instead of printing and incrementing once, I can do it twice, right? Yes. So that is nothing but a loop unrolling, guys. Got it? Yes. So you are reducing the loop cycle. So basically previously it looped 100 times. Now it is doing 50 times. So someone will be there. I will write 2 more times and I will make it 25. Yes, you are correct. You can do that also, right? Yes. Okay. Similarly, code movement. Okay, so when it comes to code movement, so assume that you are having a loop and inside loop we are initializing I equal to 0 and there is a while loop. Inside you are running this 100 times. Okay, and inside that you are adding some constants, guys. So you are adding a equal to b plus c. So does this code make any sense, guys? Because this is not dependent on the loop in the loop, right? So why did we write in the loop? Because indirectly we are executing this exact statement 100 times. Is there any need of that? No. So that is the reason why I think we can push this code outside and you can execute it before or after. So if it is not before, okay, you can do it after, right? Yes. So before or after. So based on your requirement, you can run it. So that is nothing but code movement. So you are moving the pieces of the code as per your requirement. Got it? Yes. Okay, so now I hope everyone got a clear idea with respect to optimization, right? Yes. So these are the 8 different things which you can do. So basically there could be various steps, guys, which are real-time compilers use, but these are the standard 8 things which a compiler should do. Okay, yes, to optimize your codes. Okay, yes. So now I hope everyone got a clear idea with respect to this. So in the next lecture, we'll be discussing about the program flow graph, guys. So if a program is given, how it is exactly flowing. Like, can we draw it in a graph and can we give some block numbers and can we expect how it is running exactly? So that is what, that conversion is what we'll be discussing in the next lecture, guys. Okay. Yes. And we will also discuss about liveliness analysis. So both of the topics we'll be discussing in the next lecture. Okay. Yes. Okay. So I hope everyone got a clear idea about this code optimization techniques. So in the next lecture, let us continue with the flow graphs and liveliness analysis. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.